Welcome to an overview of the LPC185x series of Cortex-M3 microcontrollers. This presentation will give a basic introduction of the features of these microcontrollers, the Cortex-M3 core, and the supporting tools infrastructure. NXP is focused 100% on 32-bit ARM-based microcontrollers. Adding to the existing ARM7 and ARM9 processors, NXP's newest portfolio members are based on ARM's Cortex-M microcontrollers. NXP's Cortex-M0 processors, the LPC1100 and LPC1200 series, are the smallest, cheapest, and lowest power 32-bit microcontrollers, and are positioned to replace traditional 8 and 16-bit architectures. NXP's Cortex-M3 processors are high-performance microcontrollers designed for maximum bandwidth and connectivity. The LPC1300 family offers pin and software compatibility to the Cortex-M0-based LPC1100 family. The higher-performing LPC1700 series offers pin-compatible upgrades for some of NXP's ARM7-based microcontrollers. The LPC1800 is the highest-performing Cortex-M3-based microcontroller on the market, running at 150 MHz. Designed using NXP's ultra-low leakage 9nm process technology, the LPC1800 family supports both high-performance and low-power operations. The LPC1800 is pin and upward code compatible with the LPC4300 family, which is NXP's first Cortex-M4 family. The LPC1800 and the LPC4300 families were designed in parallel, so the IP blocks, the peripherals, are almost identical for those two parts. The key advantage of the LPC4000 family is the powerful DSP extensions that are added to the microcontroller and the inclusion of the Cortex-M0 coprocessor. Please check out our website www.nxp.com/microcontrollers for more detail. The high-performance LPC1800 microcontrollers have a rich set of peripherals and large internal memories. Some of the distinguishing features of the LPC1800 include a 150 MHz Cortex-M3 core, highest-performing Cortex-M3 in the industry. Up to 1 MB of internal dual-bank flash with memory accelerator for near SRAM performance. The dual-bank flash allows the processor to execute from one bank of flash while the other bank is being reprogrammed. Up to 200 KB of on-chip SRAM provided in multiple banks. The State Configurable Timer, or SCT, a unique NXP peripheral capable of generating waveforms on up to 16 outputs and handling 8 different inputs. The SPI Flash Interface, or SPI-Fi, which allows an external serial memory to appear as an internal block of memory within the memory map. 2 high-speed USB interfaces, one with an internal high-speed PHY to reduce system cost and complexity. Other high-end peripherals include an Ethernet MAC, an LCD controller, and 2 CAN2 interfaces. Of course, there are also a number of communication interfaces, such as UARTs, SPI ports, I2C, and I2S interfaces. An external memory controller is available to interface to external extra memory, if the large amount of internal memory isn't sufficient for your application. The LPC1800 is based on the latest revision of the ARM Cortex-M3 core. The M3 core was designed for both performance and power in embedded applications. It utilizes a Harvard architecture with a 3-stage pipeline and uses both thumb 2 and thumb instructions. It supports hardware divide and single-cycle multiply and offers fast deterministic interrupts with the built-in NVIC, or Nested Vectored Interrupt Controller. The M3 core also has advanced integrated low-power modes and an optional memory protection unit included on all LPC1800 microcontrollers that improves the reliability of an embedded system by protecting critical data used by user applications. A wake-up interrupt controller and JTAG trace are included. The LPC1800 series offers developers a large amount of internal memory. Some members of the LPC1800 family offer up to 1 megabyte of on-chip flash. Due to NXP's proprietary flash memory accelerator, customers can run code from flash up to 150 MHz, with nearly the same performance as running from RAM. The 1 megabyte of flash is actually broken down into 2 banks, each up to a maximum of 512 kilobytes. This allows highly reliable firmware updates because the image in one flash bank doesn't have to be erased while another image is written into the second flash bank. Some members of the LPC1800 family offer up to 200 kilobyte of on-chip SRAM. The LPC1800 RAM is divided into multiple banks, which allows different bus masters to access separate portions of RAM simultaneously. This improves system performance by minimizing bus contention. Lastly, the chips include 64 kilobyte of factory-programmed ROM for easy-to-use in-system and in-application programming, and well as one-time programmable fuses. As you'd expect from a microcontroller, there are numerous communication interfaces offered on LPC1800 microcontrollers. The parts have 2 high-speed USB ports supporting host, device, and on-the-go operation, one with an onboard high-speed PHY. Some LPC1800 parts also have a 10100 Ethernet MAC. Because of NXP's flexible multi-layered bus structure, the LPC1800 series are able to run the Ethernet and USB simultaneously without bottlenecks. The LPC1800 series has an LCD controller for TFT and STN panels with resolutions up to 1024 by 768. The parts also include 2 CAN2B interfaces for industrial applications. A unique peripheral from NXP is the SPI Flash Interface, or SPI-FI, which allows an external serial memory to appear as an internal block of memory within the memory map. You can even execute code from this external serial memory. SPI-FI is compatible with standard SPI flash memory, but it's also compatible with quad SPI flash memory, which is just the same as standard flash memory, except that it has 2 extra I/O lines, so you can actually fetch 4 bits of data at a time, allowing higher performance. The LPC1800 series coprocessors have an external memory controller to connect up to 32 bits of external parallel memory, an SDIO or SDMMC memory controller interface, and a quad encoder interface, QEI, to support motor controller applications. The quadrature encoder interface connects to an external quad encoder wheel to track position, direction of rotation, and velocity. The LPC1800 includes 4 UARTs that support features such as RS-485, 9th-bit address detection, modem control, LRDA, smart card interface, and synchronous mode, also known as USART. Other communication peripherals include 2 SSP SPI ports, 2 Fast Mode Plus I2C, and 2 I2S audio interfaces. The LPC1800 series features a large number of clocks and timers for design efficiency and flexibility. There is one motor control pulse width modulator, PWM, for 3-phase motor control. The motor control PWM is highly configurable for other generalized timing, counting, capture, and compare applications. There are 4 32-bit timers, each with 8 capture inputs and 4 compare outputs, and some can generate DMA requests for timed memory-to-memory transfers. The ultra-low-power real-time clock, RTC, is on a separate power domain and has 256 bytes of battery-powered backup registers for data retention in deep power-down states. The alarm timer can also be battery-powered. The State Configurable Timer, or SCT. Conceptually, this is actually a very simple peripheral. It's a timer onto which we've coupled some state event logic. It's capable of generating waveforms on up to 16 outputs and handling 8 different inputs. A developer can design a state machine with up to 32 states and up to 16 events to create their user-defined waveforms. A graphical tool is provided to convert the state machine drawing to register settings. A library of examples containing a number of commonly used functions will be provided as a starting point. The SCT is really useful for unloading the processor from real-time controlled tasks. Included on each LPC1800 is a hardware-based AES security engine, programmable through an on-chip API. This AES engine provides hardware decryption with a 128-bit key. There are two 128-bit secure one-time programmable OTP memories for AES key storage and customer use. Analog capabilities of the LPC1800 include two 8-channel ADCs and one 10-bit DAC. The ADCs provide DMA support and a data conversion rate of 400 kilosamples per second. Input multiplexing among 8 pins provides the 8 channels of input per ADC. Features of the ADCs include power down mode, measurement range 0 to 3 volt, burst conversion mode for single or multiple inputs, optional conversion on transition on input pin or timer match signal, individual result registers for each AD channel to reduce interrupt overhead. The 10-bit DAC also provides DMA support and a data conversion rate of 400 kilosamples per second. The LPC1800 microcontrollers offer a wide range of system functions, including a flexible 8-channel DMA for peripheral to memory, memory to peripheral, peripheral to peripheral, and memory to memory transactions. A low-voltage 2-stage brownout detector which monitors the voltage on the VDD pins. Power on reset, which can hold the device in reset until the operating voltage attains a usable level. Watchdog timer, which can reset the CPU if software fails to periodically service it within a programmable time window. Each MCU has 3 phase-locked loops, one for the main clock, one to generate the 48 MHz required for the USB, and a third for audio streaming over USB. Each PLL accepts an input clock frequency from an external oscillator and multiplies the lower frequency up to a higher frequency with a current-controlled oscillator. Finally, there is a 12 MHz internal RC circuit that is 1% accurate over the entire voltage and temperature range, eliminating the need for an external crystal in many applications. The LPC1800 series is offered with and without internal flash. The flashless versions in darker green include large internal SRAM, up to 200 kilobyte, and combined with our SPI flash interface and a cheap external quad flash can provide a low-cost system solution. The parts with internal flash offer our dual bank flash in sizes between 512 kilobyte and 1 megabyte. There are 4 families within the LPC1800 series. The 181X family is the basic set of parts. All peripherals are included except USB, Ethernet, and LCD. The 182X family adds the high-speed USB, which has onboard high-speed PHY. The 183X family adds the second USB, which has an onboard full-speed PHY and a ULPI interface to an external high-speed PHY and the Ethernet MAC. The 185X family adds our graphic LCD controller. The 1812 and the 1813, or the 1822 and the 1823, may look like the same 512 kilobyte flash part, but the difference is the dual bank of memory. LPC1812 has a single bank of 512 kilobyte flash, while the LPC1813 has 512 kilobyte flash in two 256 kilobyte banks. If you don't need the dual bank capability, then you can go with the 1812. If you want the dual bank, then you can go with the 1813. And the higher flash parts intrinsically have the dual banks built in. The smaller the package, the less pins that we can bring out, obviously. So if you want full capability, choose the BGA 256 package. The 4300 part list is nearly identical, except instead of LPC 1857, it would be LPC 4357, etc. One reason ARM has become the fastest-growing 32-bit architecture in the world is the broad ecosystem of tools and support available. The devices are also supported by a number of IDE or Integrated Design Environment and compilers, including but not limited to ARM, Code-Red, High-Tex, IAR, and of course NXP's LPC Expresso, an Eclipse-based IDE. For debugging, the series are supported by any JTAG debugger that supports Cortex-M3. The LPC 1800 series is supported by multiple evaluation boards, such as High-Tech's Evaluation Board LPC 1800. The ARM Cortex Microcontroller Software Interface Standard, or CMSIS, is a vendor-independent hardware abstraction layer for the Cortex-M processor series. NXP provides CMSIS-compliant peripheral libraries for the LPC 1800. NXP provides a lot of information to help customers get started with LPC-based designs. The best place to start for more information on NXP microcontrollers is to visit NXP's website at www.nxp.com/microcontroller. You can also find training videos on YouTube by searching for LPC Zone and at NXP's LPC Zone website, www.nxp.com/lpczone. If you are interested in hearing the latest information from NXP microcontrollers, you can follow NXP's LPC Zone Twitter feed. As you start your developments using NXP's LPC microcontrollers, you can get support from other users in the LPC Microcontroller Forum.